First, thanks for sticking around. I know I'm the last person, and they just gave away the raffle prizes too, and you guys are still here, so sincerely thank you. Just to start, I sort of a quick background on why I'm even doing this. This is sort of internal, sort of like wiki notes that we have banging around our company that we sort of saw when we started looking at this stuff. We sort of saw it all over the place, and the more we started looking for, the more we were finding it, to the point where we decided, you know what, we better just sort of like just get this out here, because if we're finding this all over the place on our pen test, it's got to be in more places than people don't know about. And we're able to find some really fun ways to bypass just about every single vendor's IPS and WAF that we came up against, and we've notified them, and I think the signatures are now out there. But towards the end, you'll see some of the stuff that we were doing that was just kind of silly and fun to get past some of the IPS and WAFs, and hopefully you guys think it's as silly and fun as we do. So first off, I work for Virtual Security Research. VSR are based out of Boston, but I'm local here. I'm from the Charleston, well, I'm not from the Charleston area, I'm from Boston, but I live now in the Charleston area. I just happen to work here because it's sunny and there's beaches, and that's nice. And so this is not about 0 days in Struts or anything like that. This isn't any new exploits that nobody knows about or that sort of thing. The closest thing we get to that is just some WAF and IPS stuff and bypasses on common vendors, WAF and IPS signatures to still exploit this stuff if you haven't just patched it, which is the name of the talk. So a couple things that by the end of the talk, hopefully you kind of take away from this, is that third-party libraries are everywhere. And they're in places that you don't necessarily expect them. They're in products that you don't necessarily expect them. So you have to expect the unexpected. CVSS scores are what kind of turned me on to Struts in the first place, because we started seeing some really low CVSS scores that were resulting in full compromise of the box, so like remote code execution from a CVSS score that was like a 5, and we're like, well, isn't CVSS supposed to be like, that's like a 10, right? That's like up here if you can just hit one, send one GET request to a server and I own the server. Like that just didn't jive with us. So that's why we started looking at it, or that's why I started looking at it, and we sort of got into this whole thing. And so the takeaway there is the third one, is that your WAF and your IPS and your IDS, they're great things. I'm not saying get rid of them. I'm not in the whole, they're useless technology type crowd, but they're signature based, and signatures can be bypassed. And so, put them in place if you know that your systems have vulnerabilities, and stop that immediate exploitation, but get the patch there as soon as you can, and then keep it there as a long-term alerting. So you know when people are starting to hit your boxes with certain types of things, and it's definitely helpful in that way. But what we're seeing clients come to us is where they were using that WAF or IPS as a long-term fix for the problem. They said, well, it's going to take too much, it's going to cost too much for us to actually fix the issue. So this WAF takes care of everything. We don't have to worry about this anymore, and we can take that CVSS score and we'll mitigate it down by 3 or 4 points, and now we're looking at an adjusted score, an internal adjusted score of next to nothing, but that's still resulting in remote code execution on the box. So it's not helping you any. So why Struts? Why Struts? I just talked about it a little bit. We're sort of seeing it all over the place. It's all over the place and nobody seems to know it, is sort of the trend that we were seeing. Like I was saying before, obfuscation techniques for a couple of existing vulnerabilities that are 18-month-old vulnerabilities in this case are some of the most useful ones, but you can still just blow right through them, which is awesome from a pen testing perspective, not so good from the defensive perspective. And it's from the Apache Foundation. It's a Java 2 Enterprise MVC Framework. It's model view controller. I'll get into that in a second. And the URL for where you guys can go check out some stuff on it. It's sort of a combination of a couple of different web frameworks that merged around like 2006, 2007. There was WebWork and there was Symfony, Open Symfony, something else, and they sort of stuck together and came up with Struts 2, which is the current version of the library. And there's also Struts 1, where if I have time, we can talk about Struts 1. I think I'll probably run out before we get there. But there's some interesting stuff around that, where there's a 9-year-old vulnerability in Struts 1 that is out there and exists today. And Struts 1 is in all sorts of different products. If you check out HP Fortify's blog, they have some great information on that. So this is what I was talking about before. So this is why I started looking at Struts here. This is from 2014. It's early, say like late February, somewhere around there from 2014. It's a CVSS 5. Do you have anyone who does like the defensive side at all? If you saw CVSS 5, would that be like patch now? Would that be like patch next week? Would that be like, well, we'll roll it into this month's patches, and you know, if we have something important going on, we'll get to it this quarter. You know, right, so 5 is like, yeah, whatever, okay, we'll get there. And so people would look at this strut stuff and say, okay, fine, I have a CVSS score of 5, it's struts, but I don't use struts, right? I mean, I don't have a product that some vendor sold me that says struts on it. I don't have, you know, I talk to my developers and they're like, we don't use struts. No, we wouldn't do anything like that. But every single one of these companies has products that incorporate struts as a core piece of certain product lines. Not all of them, you know, not every product line has it, but certain ones do. Like Oracle, for example. Anyone had a Fusion middleware install or dealt with Hyperion enterprise reporting software? That stuff? No? Okay, well, it's the type of software where there's like two camps in the room right now. There's the people who don't know about it. You're the happy people. There's the people who have dealt with it, and when it needs to be upgraded or it needs to be repaired or you need to add some new feature, you call in the Oracle consultants at, you know, $400 or $500 an hour, and they give you a 6-month project plan. And then when that 6 months is up, they're not done with the work yet, so it extends out another 3 months and another $250,000, and that's pretty much how that product goes. So when somebody says, I need to upgrade Hyperion, everybody in the accounting office goes, can we find a way not to do that? And that's sort of where that whole WAF and IDS stuff comes in, right? You say, okay, well, I can put this box here. Box costs me 20 grand. It costs me $1,000 a year in signature updates, whatever it happens to be, and that's going to cover me because now I don't have to spend $1 million to upgrade this piece of Oracle middleware that nobody wants to touch and nobody wants to support. And just bouncing through the other ones real quick, PeopleSoft, that's another one of those. For anyone who's had to deal with a PeopleSoft install, you have my sympathy. I've been there, done that. And it pops up in weird places. You know, like an IBM SAN runs a Java enterprise library as part of the web interface. Like, who would have thought that? So with one series of vulnerabilities, you can pop ERP software, you can pop SANs, you can pop Red Hat Satellite. Anyone know what Red Hat Satellite does? It issues patches? Oh, for all your other Red Hat boxes? Oh, that's kind of important, you know? That's probably not good. Fujitsu, some middleware that, it was one of those names, I saw the name of the middleware, and I'm just like, this is straight out of like Office Space or something. It was like, you know, the Fujitsu like business analytics cloud platform middleware. I'm like, okay, whatever, sure. I've never seen that one myself. VMware, ops management and orchestrator products, and then Huawei, they have it in a ton of their stuff. And it's, you know, just their cloud and VM management platform, that's all. Nothing big, no problem here. But as I was looking through for all these different vendors who had struts included in them, one kind of stuck out. And most of you are probably saying, okay, fine, but I don't need to worry about struts. If all these vendors, you know, they issue patches, I get the patch, I apply the patch, boom, I'm done, there's no problem. I'm covered with struts, right? Oops. So this one I came across was 2010 was a CVE. And if you look at the struts vulnerabilities, they're not like it affects one version. If you get the one from 2014, it affects version from 2014 like all the way back to 2008 or 2006. So they were looking at this, and in their own advisory, you know, that's the advisory, you can go look it up. It says, hey, we're applying the patch for CVE 2010, blah, 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 for the Struts framework. And I'm just looking at it going, oh my God, like this sat out there for 4 years. There was a remote code execution vulnerability on a couple of Cisco products, and eventually they decided to patch it. Well, that was nice of them. To their credit, I mean, this isn't like the Cisco like Catalyst software or something like that. This was some like SIP, you know, if you're running VoIP stuff, this was some SIP interface, something like that, and some media product, and then an integrated service router or something like that. So, you know, not their core products, but big enough that you kind of scratch your head and go, you know, how did that slip through? And there's more. Custom applications, right? And that's a pink elephant in the room. So this is where we most commonly have sort of our clients. This is where we interact the most, and this is where we kept finding struts over and over and over again. We'll go into a little bit about struts and why we sort of saw it over and over and over again. It actually is a really powerful framework, and I started off looking at it thinking, oh my God, this thing's awful. You know, like there's all these vulnerabilities. It's remote code execution, like 75% of the vulnerabilities out there are remote code execution. Like, what's going on here? But once you look at what it does and how it does it, you kind of appreciate and go, oh, well, if I was a developer, I would probably look at this too, because it makes your life easy in a whole bunch of ways. So seriously, I'm not a developer. I can code, I can script, but I recognize that there's a big difference between somebody who can read some code, write a little code and script, and a developer who can create some magnificent castle of a web application. So I'm gonna give you a quick, sort of tutorial on this, hopefully get something out of it. But yeah. So it's an MVC framework, model view controller. This is a concept that's been around since like 1970s or something like that. And it's basically an object-oriented design pattern for designing stuff in a sane manner. Oh, that looks awful on the screen, sorry. It's all bleeding together. But anyway, you kind of separate your aspects of your application so that you have a user, it's a user-focused framework. You interact with a controller, have certain classes in your code that act on a data model, which is up at the top. That data model is sort of independent. You keep your classes separated, which then updates a view, and the view is what's presented back to the user. So by using something like this, you can keep your concerns and your code separated from each other. So if you need to update your data model, you can update your data model classes, and you don't have to worry about all the other pieces, and it's just a nice, clean way to do things, which is pretty much what I just said there. And internally, what it does is uses this other Apache project, OGNL, or Object Graph Navigation Language, which is this other little intermediary language which sits in the Struts framework as sort of the way that it takes a request. It takes a whole bunch of variables, puts them in an OGNL context, and OGNL can do expressions, and it's just kind of this cool little intermediary language that allows you to do simple operations on objects, very similar to Java, but it's not this great big thing. So you can pass the OGNL context between your different classes, between what Struts calls interceptors and action models and other things. So you can take them, this context object, pass it through these different classes, and it stays consistent. It's just a nice, pretty, kind of neat way to do things. But we're going to see later on this actually gets you in a lot of trouble if you expose this stuff. So the basic idea with struts is you get a Java class, you get getters and setters in your Java class, nice and simple. Sprinkle on some XML configuration files, and struts kind of takes care of everything else within its jars. So you don't have to worry about all the other stuff that goes on. Just to give you an example, this is a web application, fully functioning web application that serves up a page. That's all it is. You add in a little bit of XML in your struts XML file. Nice and simple, right? A web XML file, again, nice and simple. You can find 10, 12, 20 different tutorials online that'll walk you through doing this, and you can be up and running with a fully fledged Java enterprise app in a couple of hours tops, and that's coming from zero, from not knowing anything. So what I was saying before is that's why your developers like it. It allows them to separate their code from their data model. It presents a clean way for them to do it, and it gives them this nice, easy way for them to configure and update and maintain the app. I mean, that sounds great, right? Even from a security guy standpoint, who's not a full-time developer, I'm like, I love it. You have a way that you can keep your stuff updated. You have a way that you can maintain it going forward, and it's this nice, lightweight configuration for you. I'm like, this sounds fantastic. And on top of that, it's Java, right? There's no problems with Java. You're not on the server side, right? I mean, client side, okay, fine. But, on the server side, it's safe. It's managed, it's garbage collection, no buffer overflows. You got all these nice features about the language itself, which makes it a lot safer to use on the server side. And so the other question that was coming up, okay? Is if this library is all over the place, why aren't people finding it? You know, why is it that now that we know to look for it, that we're running into this all over the place and it's still out of date? Like, this just seems like the type of thing that this should be found a lot more frequently. And one of the things that we sort of took out of that is a lot of the reasons we think it isn't being found is because people aren't testing for it the right way. So when you're doing pen testing on web apps, you know, you look at certain pieces of the application. You look at the way that each request interacts with the server and what response you get back. And typically, you're looking at, you know, I'm going to take the cookie value and I'm going to put some crazy injection string in there and I'm going to try to see whether I can get some, you know, SQL injection, maybe I get cross-site scripting, maybe I'll have some command injection or something like that that'll come out of injecting into the value of the cookie or injecting into the value of a parameter that you're passing. But what you have to do with Struts, and I think this is true for other frameworks as well, but particularly with Struts, is you fuzz and inject your OGNL, we're going to get to that in a sec, into the paths, into the parameter names, and into the cookie names. Because Struts takes those names and in some cases directly executes them as code. Awesome, right? Or in other cases allows them to influence what code is actually run on the server side. So, oh good, it did fit. I had to tweak this slide earlier. I was afraid it wasn't going to. So the traditional sort of web app testing model, you'd start with something like what's up at the top. You know, here's a GET request to some server, got a parameter 1, value 1, and I'm going to take that parameter 1 and I'm going to set it to something that, you know, the programmer never expected or that the server doesn't expect. I'm going to watch what behavior happens. I'm going to see if I can trigger an error message. I'm going to see if I can trigger something out of the ordinary, and then I'm going to build my exploit from there. With Struts testing, and like I said, I believe with other frameworks as well, this is probably just as true, you don't want to do it at the value, you want to do the actual names. So every single place you see, you know, madness, 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 that's where you want to put your injection strings. That's where you want to try to cause the errors to occur in the application. And when you start testing this way, you start seeing Struts errors and Struts, you know, exception reports all over the place, and it's kind of crazy. Okay, so I said we were going to go back to OGNL. OGNL is that intermediary language. Remember, this is sort of it keeps the server-side context as the client is interacting with the server, and OGNL uses or uses pieces of these to build an execution stack, essentially, of things that it's going to do internally. And it can evaluate expressions on that stack as well. So anywhere you see this is where you want to try to be targeting your injections. And when you're injecting into OGNL, sometimes it's as easy as doing something like this. And this is that same CVSS 5 from earlier this year. So what's occurring here is you've got a Struts application. You've got a some parameter, you know, question mark, and then the blue is the parameter. That's the parameter name. You know, for anyone who's done web app stuff or done web app testing, you're looking at this and going, yeah, but that's not a real request. You know, it's just sort of like this blob of stuff after the question mark, and that's not really. You need an equal sign, you need a value, you need an ampersand, you need some other stuff. With Struts, it takes that blue stuff up there and turns it directly into this Java code and then executes it on the server side. And it's taking class, putting class there. It's taking class loader, putting class loader there. And as long as, in this particular example, in this particular vulnerability, as long as the method that you're calling is a public method and takes no arguments, it's going to append get, and it's going to run that. So, I mean, anyone familiar with Java security and know that when you pretty much get to the class loader, it's kind of bad news. I mean, right. I mean, there's you know, tons of stuff that if you look back over the years and you take a look at Java issues, getting to the class loader, getting to the security manager, if you can get to one of those, it's, you know, bad things are going to happen. So a quick OGNL reference. When you're crafting OGNL statements and little execution, you know, scriptlets that you want to put in there, you can assign variables. That's what the ampersand is for, or hashtag. I hate hashtag, it's an ampersand. Then you have an octothorpe, not an ampersand, right?
Ampersand
Yeah, that's the other one, right? Octothorpe is this one, not a hashtag. Yeah, got it. I don't have Twitter either. So comma separates statements. You can have multiple statements within an OGNL sort of expression. And then you've got this idea of like an array or list of collection. So you can use your brackets and either index it by number, or you can index it by key. And then finally, you can have these statement chains. So you can do something like this that kind of looks like Java. Not really, but it sort of looks like Java. And what's going to happen is it's just going to execute from left to right, straight through, and you can't see at the end. It's just a couple parens here at the end. And it's all going to be done within OGNL. That's all valid OGNL. Oops, wrong way. So the end result of this exploit here, or this particular vulnerability here, is that everything you see in orange up there, and this is on Tomcat, by the way. So on Tomcat, you'd see something like this. And what this was doing is using OGNL to call this. What you see in orange up there is in orange down here. What you see in blue up there is what's blue down there. And it's setting the document base of basically the servlet context to the attacker's source. So if you have any sort of file upload vulnerability in your web app and you're on a Linux machine, they could probably point their, your servlet is now not running your code anymore. It's not running your jar files anymore. It's running the attacker's jar files. If you have a Windows machine and you're not doing egress filtering, UNC paths are a great thing. And there were actually cases where people were just pointing Windows servers running Tomcat and running Struts and just changing the directory where it's getting all the jar files off to somebody else's server across the internet. So here your server is pulling the jar files that it's running from Asia, from Russia, from the US, from Kansas City, if you remember the last talk. And then somebody else figured out you could take a Tomcat 8, and there were some ways you could manipulate the local files, the error log files, and you can get the error log files to actually get in the same position as well. And so you could run JSPs that you had injected into the error log files by purposely calling things that had JSP code in them and would error out, get stored in the log, and then you'd move the doc base over to where the log was, rename the log to a JSP, and now you're running a JSP from the error logs of your own server. It was a really cool, fun way to, I'm looking through the whole thing and I'm going, man, whoever figured this out, that's so awesome. So just a few more vulnerabilities of this style with Struts over the past few years. For those of you who are observant, you'll probably notice a pattern. Oh, by the way, these are my notes. These are not, official CVSS notes or anything like that. This is just my internal notes of this is what you can do with this stuff if you find it. And you'll see patterns, right? So, you've got a whole bunch of them that just execute arbitrary OGNL code via param, or, class loader manipulation code exec, or the top two modify server-side context objects, but it results in code execution. And a lot of what Struts does in order to fix these issues is it takes a regular expression within the Struts framework and says, okay, that one from 2008, we found out that, if people put that hash sign in, then they might be manipulating OGNL context variables on the server side. That's bad. So we're just not going to allow the hash sign anymore, and that'll take care of it. Okay, well, except for Unicode and except for URL, encoding of those same values. And that's why in 2010, the exact same vulnerability comes up, because the regex just didn't cover all the corner cases. If you look through a bunch of these other ones, again, you see the same theme, that they're applying regexes, blacklist regexes, and saying this is bad, we're not going to let it through. And then somebody finds another way around it. And this one down here is the same thing. 2014, there were 4 different vulnerabilities. That's one vulnerability. It's just 4 failures of the regular expressions, and it's 4 failures of where they were looking, because there was no unified, security manager within Struts. It just sort of, if it's a cookie, it gets this regex applied. If it's a parameter, it gets this regex applied. And so we fixed the parameter one, and we forgot the cookie one, and that's the type of stuff that you see these same things. So a lot of these, it's really the same vulnerabilities just over and over and over again. Okay, to bounce back, just to give you a quick refresher before we move on to this. So, how bad can it be? It's just this OGNL thing, right? So what's OGNL? It allows you to do expressions. You have some commas, you have multiple statements, you have, You know, the %23, you've got some hash signs in there, so they're assigning some variables. This is something that's pulled out of, you know, existing exploit code. There's a whole bunch of Chinese blogs and sites, and I don't know why it's all Chinese. It just happens to be all Chinese for most of the Struts resources that I found, where, you know, they're just building point-and-click Win32 apps that do this. So, and this is like the tame version. This is the lightweight version of what they do. And all this is doing, if you sort of can read through it a little bit, is calling a Java process builder, feeding it the hostname command. And then if you looked at that other long line that's towards the middle of the slide there, it's grabbing the servlet response and just shoving the output of the hostname command into the servlet response and feeding it back to you. So the channel that the attacker gets the information back on, it isn't a reverse shell or something like that. It's the actual web page. It's your server responding to their request. And that's really hard from a defensive standpoint to catch, because your server is doing exactly what it's told to do, which is it gets a request, it looks at it, serves up a page, and gives it back to the user. Except that page contains an arbitrary command that the attacker wanted, not, you know, your web page, not what you wanted. So if you look at Metasploit modules, there's Metasploit modules out there for this stuff, and it just does a simple test like this. This particular one is 2013-2251, it relies on this redirect or redirect action or action, what they call a parameter prefix, which is a way that you can, in Struts, make your parameters do special things in certain cases. And if you get a modern version of Struts, all of these parameter prefixes have now been removed by default. Every single one of them was found, hey, I can do some crazy stuff with that if I just mess around with it a bunch. So if you find a site and it responds to that redirect prefix parameter, you automatically know. I either have a developer who really thinks they know what they're doing and has reversed all the defaults and is doing their own thing, and they're gonna protect it, and it's gonna be okay. Or you have an old version of Struts, and you definitely have remote code execution. You just have to figure out how to get there. And the thing to know with OGNL is if Java can do it, and these are some of the main sort of, you know, Java class libraries, so can the attacker. So they can run commands, make requests, read, write files, even load new classes. And loading new classes brings in some fun possibilities, right? So, you know, Metasploit, again, came up with a module that says, all right, fine, well, I'm going to load a Java interpreter over the internet. I'm just going to pull in the raw class files. I'm going to load them up in the class loader, and now suddenly your Java application is running essentially interpreter class files instead of your own application, or actually alongside your own application. So internally, we've been working on some stuff to do sort of like an encrypted class loader and do some fun things. We wanted to have it ready for this. It wasn't happening. We ran into more hurdles than we thought we would. All right. Too many cooks. Everyone's seen that, right? Please say yes. Okay, good. You know, I was thinking about it. I'm like, if I have 11 minutes, like. So, Smarf is later in the slides. Just wait. So payload evasion, right? So this is what I'm talking about. If you've got some of these older versions of Struts, you know you've got remote code execution. Here's some tricks. Here's some ways that we've found that we could get around. Like I said, at the time we started doing this, we were getting through every single WAF and IDS that we encountered. We've notified most of them now. They have fixed it. And so if you have the most current versions from Snort and Cisco and all those guys, then you're probably okay with this. But you know, if you didn't apply the right signatures from them, or you didn't apply signatures at all, you know, a lot of these will still work. And I really wanted to work too many cooks into this one way or another, but it does kind of actually make sense here. So what we're doing in the evasion strategies is using the different layers that your request has to go through in order to sort of, you know, security is at the seams, right? One side makes an assumption, it's not a correct assumption, or one side implements something the other side doesn't expect. And when you have these transitions between these different layers of the technology, it opens up opportunities for something to look one way over here, but when it's actually run on the other side of that interface, it means something different. And so that's what we sort of take advantage of. So when I started, you know, simple just do a GET request, and client had a WAF or IP. I can't remember exactly what product it was. Doesn't matter. And this gets blocked, right? So immediately the connections just gets dropped on the floor. Nothing's happening, right? So I'm like, okay, well, I'll just change over to a post. I'm like, holy crap, that worked. You know, just by changing from a GET to a post, I just went by your WAF. That's bad. And so we said, okay, fine. You know, they fixed the post, or we have a different product, and we couldn't get by with just a simple post. So we'll change the encoding on it, right? So normally we just do URL encoded post, no problem. That gets blocked. So we switch over and go, okay, fine. So now it's a multi-part. You know, like I'm uploading a file or something. I'm sending you a whole bunch more data, so I'm just going to change the encoding on that, and then that worked. So again, we're like, okay, well, that's really not good for the state of like the WAF and IPS industry here, if that's what it takes. But we're like, but that's still not all that complicated. You know, it'll be a simple fix. They just put a couple things, adjust the signatures, we're good to go again, right? So I said, all right, now we're going to start taking advantage of some of the differences in the different layers that we're going through. And OGNL and Java support Unicode, awesome. You know, you can URL encode things, percent encode things. That's just sort of standard web stuff at this point. So if you look in the Java docs, you can put Unicode escapes into Java code. Did anybody know that? I didn't know that before I started looking at this. No. So if you want, you know, and just for people who want to do it in other languages, or if you have some cool code conversion stuff that you're doing and you want to be able to make sure it doesn't get corrupted or something, you can just take a character and code it as an escape, you know, /u, 4 hex characters, and Java's like, cool, I'll compile that, no problem. So these 3 lines, the red, the orange, and the green, are exactly equivalent. And this is where the WAFs and this is where the IPSs start to have problems. Because, you know, new Java IO in that second line, you know, you can sort of see, okay, fine, it's kind of there. If you know Unicode, if you dream this stuff in your sleep, this is no problem. You see right through it. And then you get down, okay, we're going to URL encode a whole bunch of that stuff, and okay, you know, maybe again, if you're really hardcore into this like web filtering stuff, you can see right through that again. And the funny thing is, if you look back at Struts vulnerabilities back to 2008, 2010, this stuff was hinted at. Like the guy, he now works for Google, and I'm not even going to try to pronounce his name because I'll butcher it. And he basically said back when he found these vulnerabilities back then, he's like, you know, this Unicode thing probably isn't good, and there's probably a whole lot here that I'm just missing at this time, so somebody should probably take a look at this. And, you know, 4 years later, nobody had still. But again, there's more. So we don't stop at just Unicode and a little URL, because again, that's sort of common. That's been around for years and years. WAFs and IPSs are protecting against that. So it also turns out you can do different white space characters, and Java and OGNL will happily compile them. You know, you can have new space, tab, 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 new line, new line, new line, tab, tab, form feed, Java class. And the Java compiler's like, cool, I got that, no problem. Here's the URLs if anyone wants to look at them. It's really dry. And this is straight out of the spec. I mean, this is if you read through the Java spec, this is what you get to eventually. And cool, so we take that, and again, we roll it back into our whole strategy of how we're doing this. And if you guys haven't looked at this particular blog or site or websec.ca for SQL injection bypasses and stuff like that, these guys are, it's funny, it's comical to look through the stuff that they've figured out that you can do and to get by SQL injection filters. So a lot of what we're doing here and looking up, we're like, well, if you can do that for SQLi, I mean, why can't we do it for OGNL too, right? And so what you end up is something like this. So new Java IO file is exactly equivalent to what you've got right there. Those two, when it hits and gets evaluated, they are the same, but to the WAF and on the network, they look drastically different. So the next couple of examples that I'm going to go through, and oh well, coming up on time. The next couple of examples that I'm going to go through are all going to be this same string right here. And I chose this on purpose, and I chose this vulnerability on purpose because it's a little more flexible than some of the other ones that are out there. But it allows you to take a look, create a new Java object IO file, look at the C drive, this is a Windows machine, and then list files, and then that little bracket in the 1 is basically saying, give me the second element that's returned in the list, in the directory listing that I get. And what you'll see is that because of this redirect prefix parameter, the result of that is actually going to be spit back in the location header of a 302 redirect that comes back from the server. So this is a really sneaky way to sort of, I'm going to send a request, and you don't even know you're leaking info, but you're leaking whatever I want back here. And by adjusting the 2 that you see in orange up there, you can cycle through the entire, you can do a directory listing of the entire machine, granted that the account that Tomcat or JBoss or whatever you're attacking has access to. You can access it as well. And once you find something cool like that, right? I mean, awesome. And that's what we look for when we're doing testing. Okay. So this is the same string up top. And this is just simple URL encoding. Again, nothing special. We should be able to see that. WAF should be able to see that, no problem. Now we're going to add a little Unicode. Again, same exact string. The top and the bottom are exactly equivalent to each other when they get executed. Again, we're getting a little crazier. A little more URL encoding, a little more Unicode encoding. And now we're getting a little crazier because we're adding white space, we're adding terminators. And again, the top line is exactly equivalent to the bottom line. Those two are the same when they get executed. And then finally, this is my favorite finding when we're going through trying to get trying to obfuscate this. Java has this great feature where if you do an escape, U 4 hex digits for a Unicode escape, it'll actually take any number of U's. Like the actual regular expression that's in the parser is like U star. So you could just sort of just keep on going. Like you'd add 1024 U's and Java's like, yep, that's a single Unicode character. We gotcha. I haven't tried an upper limit on that. I just thought it was kind of funny. And finally, I mean, if you take a look at this, I mean, there's no way from a human perspective that you could look at that and say that's the same, that's the same code that we're just looking at right here. Like that top line and what you end up with here is just so massively different. And I'm sure there are those of you in the audience who are saying like, okay, but if I see a request like that, like I'm dropping it on the floor. I mean, come on, that is no way that's legitimate. And then you have to remember that you can send this via GET request. You can send this via POST request. You can send this via a multi-part form POST request. So you can include a 10 meg file in the first part of your multi-part upload, and then right at the very end, just tack that on. At what point does your WAF look at a request coming in, read a certain amount and just say, okay, fine, just let it go. It's a PDF. Who cares? So there's so many different things you can do there. And then again, what I was saying with this particular vulnerability, I chose this one as a specific example to give because you can use different prefixes at the front. So that redirect, you think, oh, well, if I see redirect, then I'm just going to block that. Okay, fine. Well, there's redirect action, there's method, there's, you've got all these different options that you can use. And eventually your WAF and your IPS rules just start looking like total spaghetti. You don't know why you put them in there in the first place. And that sort of takes us back to the beginning of, just patch it. Don't bother with this. Don't go there because the amount of effort you will have to go through in order to make your WAF or your IPS consistently pick this up and not run out of, processing power. If I decide to send 1,000 of these requests at you and it has to sit there and try to tear apart all these requests and figure out what's going on, like how many people have business rules where if you get, your WAF starts to die, they're like, no, we want it to fail closed. Like we want to deny all traffic. You're like, no, it fails open so that we can keep doing business, right? I mean, maybe that's not everywhere, but in most cases where I've run across, that's how the business wants it. That's how you have to do it. If your security equipment starts shutting down the business, your security equipment goes away, Told you there was SMARF. Okay, so what can you do? Like I said a minute ago, you can just patch it. I mean, that's really your best bet. But the problem is not often patching it, it's finding it. And that takes us back to the beginning of what I was saying. We see this stuff all over the place, but it's like people don't know it's there. I ordered these in rank of effectiveness from top to bottom. So hope your vuln scanner catches it. Probably not. You can look for action due in the URLs that are passing through. If you've got some logging going on, so okay, cool. Well, I see action stuff, I see do stuff. Like I know Struts does that. Maybe I have Struts here. Kind of lame, it might help you get there. Take a look at the parameters that you're passing back and forth. So they have a structure that looks like object.method, because that's a very common thing to see in Struts applications. So, okay, that could be another clue. Maybe I have some Struts stuff going on here. You can interrogate your vendors. Good luck with that. I'm sure they'll be very cooperative and give you their pen test results and say, yes, we have it tested quarterly, and here they are, and I'm sure that happens. You can waterboard your developer. Did I put that on there? Oh, crap, I thought I took that off. Is it too soon? And then finally, use some automation. I don't know Jeremy. I've read some of his stuff since actually doing this, because what I was going to do for this particular presentation is give you guys a little script that would run out there and take a look and hash some files and compare them and say, cool, you guys have Struts in your network. Here's a little script that you can run to tell. And what I actually ended up finding when I went to look to see if anybody else had done something similar was that this guy has done something similar and far beyond as well. So what he's got out there will actually give you a nice little report if you want it to give you a report. But what's even more effective is he has like plugins for like Ant and Maven and these other build processes that your developers, if you're doing code in-house, probably are using. So what you can do is not be the security guy who says, nope, stop, we got to freeze until I can scan everything and make sure it's secure. You can say, hey guys, include this in your build. And when you do a build, it's going to tell you whether you're using not just Struts, but anything that it has like an oval, a SCAP signature for, it's going to tell them. So if you've got this crazy old XML library that somebody threw in there because they just needed something right now, it's going to say it, and before their build even finishes, and if you can build that into your process to say, hey guys, if you have a security critical warning that comes up during your build process is not done. You need to go back and figure out what's wrong with that and make it one of the goals of your build process is that you come clean on a security scanning for out-of-date third-party libraries. And with Struts, it's important to note that, I think I alluded to it earlier, they've changed a lot of defaults. So if you go from like a 6-year-old Struts install and you go ahead and just go up to the latest version, you're going to break a whole lot of stuff. Things aren't going to work. The regular expressions that they put in place in some cases blocked totally legitimate applications. So if you use the word class in one of your objects that you legitimately put into your application, I mean, a lot of developers do that, right? It just sort of makes sense to them. The name of the object is the something class. Well, okay, we have a regular expression that says you can't use the word class in a parameter. All right, well, your whole app is broken if you just upgraded to the secure version. So, and those other parameter prefixes, things like that are gone as well. So it's not as simple as just dropping in a new jar file and going, but it's definitely worth doing. And so what I would do personally, if I were on the defensive side, is build this into your overall process. Say, hey, look, guys, we have Struts here, but this is indicative of a larger problem. And if you guys have seen the OWASP, the top 10, number A9 from 2013 is using out-of-date components. So use something like this as an opportunity to say, we're going to build in an OWASP A9 plan into our build process. And you'll be better off for now, and you'll be better off for later. Go ahead and find Spring, Rails, .NET, XML, Visual C++ libraries that are out of date that you're including into your developers are including into their software. And it takes us back to the beginning, which is the takeaways. Third-party libraries are everywhere. Struts is just one example. It's a particularly bad example. It's a particularly fun example from a pen testing standpoint. Your CVSS scores are only as good as your understanding of your own environment. And you have to look at them carefully. You have to look at them critically and say, okay, is a 5 really a 5 for us? And that's not an easy job, and it's not a simple thing to do. And then again, your apps, your WAFs, your IPS, your IDS, they're great to have, but don't rely on them to permanently fix a problem. That's all I got. Questions?